Wednesday, we will do a practice one of these, okay? This is why we learned the unit circle, is so that we would be able to do this, as I keep saying to you. And I'll go through this process again with you. But remember, my whole process is start with the denominator, gives you your ordered pair. Numerator gives you the quadrant, hence the signs. Then cosine is your x, sine is your y. Or is it one of your tan tricks, which are one of those three numbers, pretty much, unless it's the quadrantal. So we'll go over all of that. That is on Wednesday. Yeah. Get what paper? I haven't printed it yet, but you could stop by later today and get it from me. I can print it during my planning, which is helps great since you stop by later. Yeah. So listen, if you got a 30 out of 30 on the unit circle, you're good, okay? You just want to study your tan values, make sure you know those tricks, okay? But I am going to go over all of that tomorrow with you guys, because this is really where it's at. You have to have the unit circle imprinted in your brain to be able to do the trig in the world, any trig, to be able, which is this. What is cosine of 3 pi over 2? What's tan of pi over 4? And all of those, okay? So that's what's coming up. But today we are doing something, we're still working with sine and then tomorrow cosine, but we're graphing now. And the graph of these are really, really, really simple. You're going to see, okay? And so what sine and cosine are periodic phenomena. You might remember from the beginning of the quarter, or this unit in 3.1, that was what it was called, periodic phenomena. And we learned about amplitude, we learned about midline, we learned about the period, and it was all those funky looking graphs. We had to see like, oh, it looks like a W, and then it repeats as a W. And I told you then that when we get to sine and cosine, those are just specific types of those graphs, and they're so much easier than some of those weird ones we had in 3.1. You're going to see these are pretty simple. Okay, so the sine function matches the measure of an angle in standard position with the y-coordinate of a point. So we are going to make a table of values here in a minute, and it takes thetas, and then sine would be the y values at those thetas. That's kind of like your ordered pair, you'll see. And we call that graph a sine curve because it looks like a curve or a wave. I've heard it called sine wave. Graph is fine too. And don't forget, sine is the y-coordinate, right? Cosine is x, sine is y. So one time and one time only, we're going to make a table of values so I can kind of teach what sine graph is, but you'll never have to do it again. There's just a little cutesy little pattern to graphing these that makes all graphs of sine. And then tomorrow cosine, really, really simple, okay? So stay with me for a minute. This XY chart is already started for us. A whole bunch of X values are chosen for us. Those are thetas. And you should recognize, those are all unit circle angles, standard angles on the unit circle. It's the quadrantals, the 3s and the 6s. It looks like the 4s were left off. No big deal, just had to pick some and want to do the whole unit circle. So what we're going to do is fill in the y values at each of these signs. So let's use this as an opportunity to kind of practice with ourselves. So remember, these are your thetas. So at 0, think of the ordered pair, 1, 0. So sine would be 0 at angle 0. Then pi over 6, that's your first one. Picture it. That's why I keep giving you this information. At your denominator of 6, we start with the square root of 3, right? Keep saying that. I keep saying that. So sine is the other number. You know how it starts. That's cosine. So sine is 1/2. And your denominator of 3 is going to be the flip of that. Oops, that's a 3. Okay? Any of my denominators of 2, that's a quadrantal. That's at the top. 0, 1. Picture it. 0, 1, right? Then my denominators of 3 are all going to have the same sign value. Remember, the ordered pairs are the same for all of your denominators of your thetas. The only difference is the SIGN, the sign, okay? So denominator of 3, denominator of 6, these two angles are in quadrant 2. I know that super fast because the numerator is 1 less than the denominator. Quadrant 2, cosine is negative, sine is positive. So those are good. Then I get to pi. That's -1 is my cosine, 0 would be sine. Now I'm in quadrant 3. Denominators of 6, 1/2. Denominators of 3, square root of 3 over 2. But quadrant 3, Numerator is 1 more than the denominator. That's positive, negative. All my sign values are negative in that quadrant. That's how fast it needs to be. Like, you don't see me I don't just rattle these off. I go through this process. 3 pi over 2 at the bottom. That's 0, negative 1. And then my denominator of 3, my denominator of 6. I'm in quadrant 4. The difference between those numbers is more than 1, so I know it's quadrant 4. That's positive, negative. There they are. And then back to 2 pi, which is coterminal with 0. Okay? So let's answer a few questions about these ordered pairs. Okay? Where are the y values increasing? So what interval? So interval is what chunk of the x values are the y values going up. And so this is kind of tricky, not tricky, but it's easier to know, which number is bigger or smaller if we're in decimal form instead of fraction form. So this is 0, 1/2 is 0.5, and I put this in my calculator, guys. Square root of 3 over 2 is 0.87. Okay, and it's just going to keep repeating. So I'm just going to do this real quick. It just is going to help me see where the numbers are going up and where they're going down. Okay, so I just converted all my fractions to decimals, but remember, it's the same fractions over and over again, so it's not really labor intensive. So what we want to know is where are the y values increasing? So down here in pink, those are the y values. So I'm increasing from 0, right, 0.5, 0.87. I'm still increasing until I get here. Then it starts going down again. So I'm increasing from 0 to pi over 2. I'm increasing. My y values are increasing. The way we name that, the word interval means x values. You can use brackets or parentheses for that. Okay? You'll see both. Then we're going down, right? 1, 0.87, 0.5, 0, into the negatives, negative 0.5, negative 0.87, negative 1. But then guess what? At negative 1, we start going up again. So from negative 1 to 0, these are increasing as well. So we have another chunk of the graph where we're increasing, which is from 3 pi over 2 to 2 pi. And we'll see what this looks like on the next page. And where we're decreasing is going to be that section that wasn't increasing, right? We are decreasing starting here. We go from 1 all the way down to negative 0.87, and then it starts going up again. So they overlap. So look, from pi over 2 to 3 pi over 2, we're decreasing. That's where the battle comes in between math people, the really smart math people, about whether we should use parentheses or brackets, because we overlap. Like, is pi over 2 part of the increasing or part of the decreasing? Well, it's both. Okay, depends on which way you're looking at it. That's why I like parentheses better. I'm saying it's not included, but then some people are like, yeah, but it is included. So that's why there's a whole debate. Parentheses, brackets, doesn't matter. When do the parentheses matter or brackets? Is concavity has to be parentheses. Okay. Last part of this before we finally get to the graph, and that's where's the min and the max, right? The max point is the highest point, and the min is the lowest point. It's a point, so it's an ordered pair. So we would use parentheses for a point, okay? So look at them. What is the highest point out of all of those? And so remember, what makes a point go up or down is the y value. So the biggest y value we have is 1, right? So pi over 2, 1 is our max point, and our lowest point would be 3 pi over 2, negative 1. Negative 1 is the smallest number there, and y value, and y is 1 is the biggest number. So 1 to negative 1. High as it goes is 1, low as it goes is negative 1. Now, when we graph sine, we always use 5 key points. 5. Now, we just picked a whole bunch of points, because if it's curvy, it's going to hit every single standard angle, including the denominators of 4 and everything in between. But we picked these numbers, or she picked those x values for us because they're easy ones on the unit circle. But now we can narrow it down to 5 points. And the 5 points we use are the easiest ones to graph. I would rather graph whole numbers than any fractions. So we end up just using our quadrantals. 0, pi over 2, pi, 3 pi over 2, 2 pi. Because look, we don't have to graph any fractions. Those are, from here on out, our 5 key points of the parent function. So let's write them, and I will explain how we will use these in the future. You won't ever have to use the ordered pairs again, but trust me, this helps to help us understand. So out of that chart, I just grabbed the 5 key points that we decided to use. Okay? And what we just found is those are the 5 key points of the parent function of sine. Okay? And so what that is if you look at my graph here, this is 0, 0. Then we have pi over 2. There's that max. Then we have pi 0. And then we have 3 pi over 2, negative 1. There's my min. And then 2 pi 0. So from here, 1, 2, 3, 4, 5. From 0 to 2 pi is one period of the sine function. Remember, the word period means what chunk of the x-axis do we use to make one cycle? And now let's make it easier. How much of the x-axis do we use to make 5 points? 1, 2, 3, 4, 5, from 0 to 2 pi, that would be a period of 2 pi. Okay? So our parent function is always 2 pi. Now, just like every other graph I got ahead of myself. Remember I said there's a cutesy little pattern? Look, watch my pen as I say this. Middle, up, middle, down, middle. Mid, up, mid, down, middle. From here on out, that's what you know about sine graph. You start in the middle, you go up, go back to the middle, go down, and then middle. Because I'm going to do some examples here with you without using ordered pairs, just using that pattern. You're going to find it super easy. Tomorrow's notes for cosine, you're almost going to be like, wait a second, she's lost it. We're doing the same exact thing as we did yesterday. The notes are identical, except for cosine. The only little thing that's going to be different in tomorrow's notes is this pattern. Everything else is going to be the same. So start memorizing it today. Every time we graph it, almost say it to yourself. Middle up, middle down, middle. Okay? So what's going to happen, though, is we don't always just graph the parent function. We're going to change amplitude, period. We're going to start putting midlines in. Later, we do something called a phase shift, which are not fun, but we have to deal with them. So let's just talk about some of the basic characteristics or properties of the sine function. The domain is all real numbers. That is just one period. But just like the unit circle is like one cycle, it goes from 0 to 2 pi, you can keep going and going and going and going, forward and backwards, and the graph would just keep going. So this is just one period, but you can see it can just keep going and going in both directions. So the domain, x values, could go on forever and ever, okay? The range of the parent function is from -1 to 1. Remember, that was our highest and our lowest. Will that change if we throw some other letters in? Amplitude is represented by the absolute value of a, okay? And we've talked about that in periodic functions, but guess what? A is right after the equal sign. Just like a in every polynomial equation we ever do, we put an a value there. What does it do? It vertically stretches or shrinks it. It can flip it if you put a negative in front. Okay, so we're going to see that. The period is going to be 2 pi. So write this. The period of all of your graphs are 2 pi, unless there is a b value. B is going to be a number that hangs out with x in the parentheses. So you will have to do a little formula of 2 pi divided by b. 2 pi is always in the numerator, and you divide it by b. So just make the connection that in our parent function right above, b was 1, right? There's a 1 in front of the x if you don't see anything. So if you do 2 pi divided by 1, you just get 2 pi. So that's why the parent function is 2 pi, okay? But b is going to get thrown in there. b will affect the period, okay? b will affect the period. So what you're going to see is sometimes you're given the period and you have to find B. Sometimes you're given B and you have to find the period. Know this formula, but if I need to solve for B, guess what? It's the same exact formula. If I rearrange this equation, guys, without doing it, if I solve for B instead, I would multiply both sides by B and divide by the period. It doesn't change the fact that 2 pi would be in the numerator, and I will bring you back to this moment, but period and B are entangled together. Sometimes you're given the period and you need B, sometimes you're given B and you need the period. Remember the formula? It's always 2 pi on top divided by what I was given. That will give me the thing I need, and I'll come back to that. This is probably the only thing you'll have a question on at first, so just know where to find that. Okay, so let's look at our first example. Now, I just told you you were not going to have to make a table of values, and I'm not going to make you make a table of values. I want to explain something now. We start, the key points are mid, up, mid, down, mid. That's that little mantra. Middle, up, middle, down, middle. Okay, because the only thing that changes tomorrow is that. It's the only thing. Okay. So remember, sign starts in the middle. That's a good way to start. Sign starts right in the middle. Okay, so we have 5 key points that we just came up with for our parent function. And the first 2 are 0, 0. Let's just do 2 of them. I'm not going to make us do them all. Those are the first 2, right? And it continues. Now, here is our new graph, where amplitude is now 2 instead of 1. Remember what that does to your ordered pair. And this is something I want you guys to know. I didn't make you do these in the homework, but it's important that you guys remember something, so I'm going to point it out to you. Whenever there's a new rule, meaning something is done to the parent function point, so there's the parent function point, remember, that anything on the outside of these little parentheses affects the y value, remember that? And anything inside affects the x value. Well, this is a vertical stretch by factor of 2. It's going to change all of my x values. I'm going to multiply all my x values by 2. Now, we don't have to do this, is my point. Watch what we're going to do instead of having to make new ordered pairs. So much easier. You say, okay, I need to know my amplitude, and I need to know my period. I need to know how long this is going to be, right? So all I'm given, though, is B. You're given B here, right? B is 1. If I want to know the period, I have to do 2 pi. Remember, 2 pi is always on top, divided by 1. Sorry, this is where I am. To find B, I'm doing 2 pi divided by the B value. Which is, let me do this differently. Let me say it differently. Sorry, guys. B is 1, right? That's the B value. But I want to know the period. How do I find the period? 2 pi, always on top, divided by the B. So that would be 2 pi. Did I need to do all that math? Going forward, just know if the number in front of your x is 1, it's the parent function period, which is 2 pi. What does that mean? Remember with periodic functions, you always start and end at the same y value. So middle up, middle down, middle. That's how wide my period is going to be. And then I just follow through. I'm going to go up to 2 instead of going up to 1 because that's what's going to happen. My amplitude is how high and how low I go. So middle, up, middle, down, middle. And notice I'm hitting those quadrantals that are labeled for me on the x-axis. That is all of those points if I multiply the y values by 2. I don't need to. I just know I'm going to go up to 2 and down to 2, right? So there's an example of one where just the A was changed. Let's keep going. Example 5 at the bottom of the next page, please. Use the 5 key points. We're always going to do 5 points. Let's look at the given equation and pull all the important information out, okay? We are given an A value of 3, not negative 3, but we know that negative in front means we are going to have to flip our graph over the x-axis, okay? We are given a B value of what? What's B? 2. Right? B is the number inside the, did I not say that? B is the number inside the parentheses. Yeah, I think I did. Inside the parentheses with the X. B is 2. That's not the period. The B value affects the period. Remember, the period is 2 pi, and then that B value is going to change it. It's always 2 pi on top divided by that B. 2's cancel. Our new period is pi. What does that mean? It means we start at 0, middle, and we're going to end in the middle. 0 and pi. That's the length. That's how much of the x-axis, pi. And then I'm just going to fill in the spots in between evenly. So instead of going middle up to 3 and then middle down, I'm going to flip. So instead of going middle up, I'm going to go middle down. Middle up, middle. That's what a flip does. Just so you know, that rule to all those x's, there's something being done to the x value inside, and there's 2 things happening to the y value. So the negative and the 3 would affect the y values, and the 2 would affect the x values. And do you remember you flip it? So if you had to come up with a rule, but I'm not making you guys do all that, okay? I would rather you know it by the pattern. That's how we graph these, okay? One more. We have an A value of 2 and a B value of 1, right? New letter, guess what that is? It's called D. C we haven't been introduced to yet. D is your midline. Think about what your midline does. It changes where your x-axis is. It moves it up or down. That's like what K does to all of our like polynomial graphs, right? That number all the way to the right takes all your points up or down. That's going to take all of our points up too. We'll actually start with that, but there's one more thing I need, and that's the period, right? Remember, the period is 2 pi divided by B. Whenever B is 1, like here, it's just going to go from 0 to 2 pi, but don't put those points on it. Because whenever you have a midline, let's start with that. My midline is right here at positive 2. That was given. And then my amplitude is going to be 2 above that and 2 below that. And the rest is just following the pattern. So I'm going from 0 to 2 pi. So we start middle. This is my new middle, right? Middle. Then it's not a flip, so where am I going to go? Up, up, middle, down, and then ending where we started. Middle, up, middle, down, middle. It's just our middle is now our midline instead of the x-axis. That's the only difference. Midline is nice and easy. It doesn't hurt us too much. And that's it. Okay? I'm going to do the first half of the homework with you, 1 through 6. So please get ready for that. And after that, if any of you want to do the 5-minute quiz, we can do that. Or you can wait till tomorrow, or you can just skip to the 4 minutes. It's up to you. All right. So here's the direction. Find the amplitude and the period, and write an equation for each curve. I'm not going to make you do that last time. Okay? So we didn't have any in our homework like this. So just stay with me. You're going to get your homework done in class, okay? So what I want to do first is find amplitude, okay? So my amplitude is, I'm going up to 3, I'm going down to 3. So A is 3. And notice it's middle up. So that means there's no flip, right? If this went middle down, I would think of this as a flip. It's not, okay? I also need B. Well, I don't have B. You can't tell B necessarily just by looking at it. What we can get off of a graph is the period. Remember, you're going to count 5 points. Middle, up, middle, down, middle. there is one period of the graph. How far out did I go? 2 pi. So my b, remember, always put 2 pi in the numerator and divide by whatever one you have. The other ones we were doing, if you were given b, that one in the denominator. Here we have the 2 pi. But once you saw that your period was 2 pi, start making that connection. That's the parent function. B is just 1, right? Now write the equation. Y equals 3 sine 1x. We don't need to put a 1 in front of our x. That's it. Okay. Look at number 2. Let's start. Amplitude's always the easiest. We're going up to 2, down to negative 2. Amplitude is 2. And we're going middle up again, so there's no flip, right? Middle, up, middle, down, middle. Right there is 1 period. 5 points, 1 period. So my period is what? I think it's pi. Okay, right? 1, 2, 3. I think that's a pi. Can you see it? Back. It is pi. This is 2 pi over here. Okay, but that's not b. Remember, period and b are joined together. To find b, I do 2 pi always, divided by, in this case, pi. So now I have a b value of 2. Y equals 2 sine, put parentheses, 2x. Good? Okay. I'm going, down first. Down to 2, up to 2. So my amplitude is 2, but there is a flip. Because look, I go middle down instead of middle up. That means a flip. Let's find our period. 1, so middle, down, middle, up, always end where you started. So, Zach, what's that period? Yes, 4 pi, but that's not b, remember. B is 2 pi, always on top, divided by 4 pi. Pi's cancel, 2/4 is 1/2. So y equals 2, but with a flip, parentheses, 1/2. Last one of these, I'm going up to 2 and down to negative 4. Remember, when that happens, that means we have a midline, okay, when they're not the same exact number. So let's review how to find the midline. We take our max, which is 2, plus our min, which is negative 4, and we find the midpoint between them. Add the two numbers, divide by 2. So we have a midline right here at negative 1. Why is that important? Yeah, good. It's our D value, which we didn't have one of those yet. But it also helps us find our amplitude nice and easy. So 1, 2, 3. So my amplitude is 3. Is there a flip in this one? Yeah, middle. Well, I should call this my middle, actually. Middle, down, middle, up, middle. So from here to here. Right, my middle is really the so middle, down, middle, up, middle. Start and end at the same place. So first of all, yes, that's a flip because it goes down. And then my period is hard to see. That is pi. 5 points from 0 to pi. B would be 2 pi divided by that. And like Zach said, D is going to be negative 1. Y equals 3 with a flip, sine, in parentheses, 2x minus 1. A, B, D. Get plugged in. You guys seem like you're getting this pretty well. Doing okay? All right, but I'll do two more with you. Now you're graphing, given some information, and write the equation. Assume A is greater than 0, meaning there's no flips, okay? So we have an amplitude of 3. And to be able to write the equation, guys, I need B. Remember, period is not B. B is not 2 pi. Period and B just have a relationship. They're not the same person, okay? And so to find that, we would take, to find B, really simple, guys. Remember, a minute ago we were trying to find, well, I guess we were trying to find B there too. So it's 2 pi, that's what they gave us. They told us the period is 2 pi, divided by 2 pi. So the period, when the period is 2 pi, B is going to be 1, right? So there's the equation, 3 sine x, 1x. No flip, start in the middle and end at 2 pi, right? From 0 to 2 pi is the whole period. And I'm just going to hit those quadrantals, middle and going up to 3. Middle up, middle down to negative 3, middle. And smooth curve, there she is. A is 2. To find B, we have a formula, 2 pi divided by the period. So B would be 2. So this is everything we need, right, to graph it. But we had to do this little formula to find the B value. We need A, B, and later C, and maybe D to write the equation. But really, amplitude of 2 with no flip going from 0 to pi, right, that's the whole graph is going to go from there to there. So I'm going to go middle up to 2, middle down to 2, middle. Right? So guys, you're going to the next page and you have the rest of it to do. 9 through 12, you have to cut the x-axis up however you want. It does not have to look just like mine. You could make it tighter together, more spread out, as long as, you know, all 5 points only go out to 2 pi, or all 5 points only go out to 4 pi. I could have squished this in closer. So just know, when you get to the 9 through 12, this is just one way of looking at it. You can change your x-axis however you want, as long as you're doing the right amplitude, only going 5 points out to that other value, and so on. Caitlin, what did you decide you want to do, hon? Today, tomorrow, today? Does anybody else want to do their 5-minute today? Okay, Sam. Can each of you grab your phones and do a timer? Is that okay? Okay. It's just going to be easier since you guys aren't sitting together.